Okay, so maybe I don't have it. Okay.
Oh, now lock the focus.
Focus.
Lock.
Okay. I was walking through the math suite this morning, and I said, "Oh, look! I guess Nader and the Finnegans were here early for the first week, but it's 8 o'clock and they're not here yet." Tony reminded me this is the 8th week. Last week it seemed like the first week of the semester to me. In reality, it was what, week number 7?
Yeah.
Oh well. Okay, Tony, make your announcement.
Okay, we're going to continue discussing functions this week. We defined functions on Wednesday as a rule which assigns to every x value. Do y'all remember how many y values? Just one. Not 2 or 3, but only one y value. And we're going to discuss, let's see, I think we're doing 2 different types of functions today. Piecewise functions and quadratic. If you know what the word pieces is, then you can figure out sort of what a piecewise function is. Quadratic means it has an x square in it. We've already seen that. And we're going to do some operations on functions on Wednesday. Add, subtract, multiply, divide. Then next week is spring break. One more lesson 2 weeks from today before we review for our test. The second test will be 3 weeks from today. March the 23rd. So this is my way of announcing when the test is coming. Let's see, I think all of these, let's look at this list of his homework assignments. I think all the homework assignments are open. Scan on down. Let's scan down. Let's see. So this upcoming test is going to cover, which it's 3 weeks away, okay? So it's not time yet for a test. It seems like we just had the first test. Homework 9, lines, circles, functions, and then we'll continue discussing functions. You'll notice above each assignment at this point, in case you're feeling, you get up and you're sick, don't come to school, especially if you have a fever. There's separate videos for, here are the little videos that I've made in the past for assignment 12. Now, let's go back to the home page.
Realize those videos do not show how to use the graphing tools.
Yeah,
okay?
because it doesn't show that computer screen. The new videos, I have a new announcement here. It says this link takes you directly to the playlist that we're creating for your class. As more videos are made, they'll be added to the end of the playlist. So when you click there, it takes you to the YouTube playlist. And down here towards the end, this is what we did on Wednesday. There's the class announcements from February 26th, and then the lecture over functions. Okay? What's the difference between these videos and the ones that are built into the assignment? Well, these are the videos I'm making right now. We're making right now. Okay? Notice there's no video yet over what we're going to do today, quadratic and piecewise functions, because we haven't done it yet. But over here under assignments, these are the videos that I made in the past. Okay? So y'all's videos that I'm making right now will one day be the past videos for future classes. Okay? So, volume's down. Huh? No. Okay? Even though my math lab will want to put a grade on them, it doesn't matter. It doesn't affect your homework grade.
Now realize some of the assignments towards the end, the logarithm assignments, for instance, which isn't shown yet, those things already have the videos built actually in the assignment.
If they're in the assignment, you got to
click it. If it's a separate thing, you do not have to click it, okay? And here we go. with piecewise and quadratic functions.
Okay, let me label this. So we're looking at, this is lesson 12, piecewise and quadratic functions.
Oh. What do y'all think of putting the attendance sheets by the door? Sign as you come in, because I know passes around in these big classes, invariably 10 people miss it.
So, make it a little bit bigger. And move this down a little. And, well, there's not a lot for me to say before we just jump into an example, provided you remember what a what a function is. With a function, every x value gets exactly one y value. We had some problems like this. Suppose we have f of x equals 5x minus 7, and you were told to find f of 10. Do y'all remember what you do with that number in the parentheses? You plug it in for x. Whatever the number is in the parentheses, you plug in for x. So like f of 10, 5 times 10 would be 50 minus 7, 43. For every x value, there can only be one y value, not 2 or 3 y values. Okay? So every x gets exactly one y value. Let's go ahead and just jump into problem number 2. 2 is a good one to start with.
A piecewise function is a function that is defined by more than one piece. I know that's a terrible definition because we're using the word piece in it, but notice this function is defined using 3 pieces. You'll use the piece negative 2x minus 12 to find your y value if your x value is less than negative 5. When your x value is between negative 5 and positive 5, notice we're including negative 5. Notice the little equal bar, but we're not including positive 5. Then in that event, the y value is just 5. If the x value you're using is greater than or equal to 5, then we'll use the piece x plus 7 to find the y value.
Ooh.
I like to make each piece in a different color.
Me too, and I've already miscopied it, so I'll just start all over with another sheet of paper. Negative 2x minus 12 for x values less than negative 5. That second one, just a 5 for negative 5 less than or equal to x less than 5. That middle statement there, don't read it the way I just said it. When you see a statement with 2 less thans or 2 greater thans, the way you should read it so that you understand what the heck it means is to start in the beginning, in the middle and say between. So that second rule is h of x equals 5 for x between negative 5 and positive 5.
Including negative 5, but not including positive 5.
That's an H. I wrote it with the F, so we'll have to pretend it's an H. So, oh wow, this is one of those multiple part problems. The first thing we're told to do is find H of negative 7. Remember what we said earlier. For a function, every x can have only one y value. So, that's supposed to be H. I wrote an F, but I corrected it. So, let's see. The number inside the parentheses, the x, we're going to plug that in for y. But which, we're going to plug that in for x. But which piece do we plug it into? You're not going to have a black, a red, and a blue answer. You can only have one answer. one y value. So the way you decide is you look at the number in the parentheses, and then you look over here. You're going to use the black rule if your x is less than -5. We'll use the red rule if our x value is between -5 and 5. You'll use the blue rule if your x is bigger than 5, greater than or equal to 5. Here's my x value, -7. Is it smaller than -5, between -5 and 5, or is it bigger than 5? Which one? Is -7 less than -5? Is that where it is? It's not between -5 and 5. What's between -5 and 5? -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Or bigger than 5. So which one are we thinking we're going to plug it into? Just that first one, the black one. -7. Put a -7 in for x. So -2 times -7 is a +14. Minus 12 is 2. For every x, there can be only one y. A function is a rule which assigns to every x value exactly one y value. There's the one y value. So let's type in 2, get a correct answer, and it'll tell us another number to plug in. What number does it say to do that?
H of 4.
H of 4. Well, let's look back at the rule. Where does our x value lie? Is it less than -5, between -5 and 5, or bigger than 5? It's between -5 and 5. Now notice this function looks a little strange because over here in the red there's not an x. That's called a constant function. It doesn't matter what the x value is, the y value is a 5. It's called a constant function. So the x value 4 is being assigned the y value 5. If you wanted to imagine those little tables we had the last time, like this, I'll move it over. Like that. I remember the way we had some problems where there were little arrows drawn. Okay. So, let's see, type in a 5 and, let's see, H of 5. So, H of 5. Now this one goes back to what my brother was trying to say a while ago. Remember, for every x value there could be only one y value, so we can't plug it into the red one and the blue one. Which one allows x to actually equal 5? The blue one is the one, you see right here it doesn't actually say x equal 5. Okay? So I'm going to plug in here 5 plus 7, so a 12. Y'all see how I'm choosing which one to plug into. It's sort of unfortunate that it looks like it's just going first rule, second rule, third rule. Well, see, what's this next one? H of 8. Which one would I plug into there? Which one? The blue one? The x value is bigger than 5, isn't it? Yes. So 8 plus 7, 15. And that finishes the problem. But here, let's just make a different one. Let's do this one. Here's one. We'll go back. Suppose that it said find h of 0. And now we're through with the problem. I'm just made this one up. Okay. Which one would we plug in to find h of 0? Where would 0 lie? It'd be between the negative 5 and 5, so it would just be a red 5. Now what about h of
Pi. H of pi.
Oh, I'm not going to do that, Tim. 3.14, no.
Well,
Well,
where would they're smarter
Yeah.
than you think, Tony. 3.14, where would it be? Which one? The first, second, or third?
that Greek letter pi, the circumference of the ratio of the circumference of a circle to its diameter. You may have seen it in geometry.
The second one, 3 point anything is between negative 5 and positive 5.
Okay.
So it'd be another positive 5.
Okay, so now let me do the one I wanted to do. H of negative 10 and H of positive 10.
There. I am learning something.
Okay, so H of negative 10 and H of positive 10. So H of negative 10, which one would we plug that one into? Negative 10. Okay, you're doing the positive 10, you're ahead of me. And this, you know what, it looks like I put a dot there, but it's not supposed to be a dot.
Just make your 0 bigger.
Okay, good. H of negative 10, you would plug in up here, and the first one, negative 10 is less than negative 5. So negative 2 times negative 10, that would be a 20, minus 12 is 8. And what about the last one? H of positive 10, which one would we plug into? The blue one. 10 plus 7, 17. Is it clear how I'm deciding which of these to plug into? Okay. Now, the next thing we're going to,
We're doing two things with piecewise functions, evaluating them. That's what we did with number 2. The thing that's going to take the most time with them is graphing them, and we're moving on. We're not going to go in the order that we have there.
No,
we want
6. Go to
we want to
problem
go to
6.
problem 6. The thing. Oh, and you. There is not a piecewise graphing tool built into this MyMathLab course. So for piecewise functions, we're going to handle it just with multiple choice graphs. We'll graph using graph the thing on paper, and then we'll pick the one that looks the closest to it. I'll do this one.
You sure you
Yeah,
want to?
I will. Yeah.
Oh, you're going to do that? Do it like that?
Okay.
Are you sure you have enough marks?
Oh, yeah.
Oh,
I was looking. I think I do. Yeah. But everyone else doesn't have graph paper. Now, after this problem, where's the graph paper? This problem here is going to give us some y values that are pretty big, like 15. And the little graph paper we have doesn't have 15 marks for you to count up. So I made myself a nice little graph paper, just like a little piece of graph paper, just like this. So,
If you look at graph paper, I have someone pass them around. Maybe they're too small.
okay, but y'all are writing this problem down, right? Okay.
I label each piece a different color.
I'll do the same thing, Tony. Let me write it down. This is y'all's problem number 6. How do you know if it's still recording? Is it still recording?
You got to look right here. Oh, Tim, I just realized.
I never started recording.
We never stopped it. It's the announcements and all of this are on just one video.
Oh my God.
Well, it's okay. There weren't many.
I didn't write the problem down, Tony.
Oh.
Okay, so the first piece, we'll use 2 plus 3x if our x value is less than negative 4.
Wait a minute. What? Oh, it is still recording. Oh, okay. I was about to say it's not recording.
Well, I didn't see the second piece, Tony.
Oh, okay.
We'll use negative 2x if, what do y'all think of my cursive writing?
I don't like cursive.
I try not to, but for this I do. They say they're going to start back teaching that in public schools. Have y'all heard that? cursive. Okay. And we'll use the piece 2x if our x value is greater than 5. So we're going to have the blue rule for x is less than -4. The purple rule, well, y'all can't see its colors yet. And they can't see your cursive writing either, Tim. Oh, let me show them my beautiful cursive writing. You did win the penmanship award in the 2nd grade, didn't you? And the 3rd and the 4th grade, I might add. I'm sure I won in the 5th grade also. I had perfect penmanship. Doesn't do to peak early. Remember Donnie and Marie? No, y'all don't, okay? So, but still, they peaked early, and look at them. So we're going to have 2 graphs. Now, here's something that I do that I want to mention, Tim. I call these numbers over here cut points. I do the same thing. Oh, okay. Because they behave very much like cut points. And when we're doing the cut point method, y'all remember with cut points, you always had the open or closed circle. And you'll see why I call this cut point. So I'll let you continue on, Tim. We're going to plot these things, we're going to graph these piecewise functions by plotting points, but we're going to plot points intelligently. We're not just going to start randomly choosing x values like we did in number 2. They were just sort of randomly giving us x values to use. Here we're going to plot the points, but we're going to plot the points intelligently. And look at the 3 pieces. Y equals 2 plus 3x. Y equals -2x. Y equals positive 2x. There are no exponents on the variables. What would you expect those graphs to look like? Y equals mx plus b. What would that be? If there's no exponents, no absolute values, no square roots, generally what's the graph then? A line. L. That's yeah, right. It's going to be a line. What's the minimum number of points we need to draw a line? 2. 2. Okay, so we're going to find 2 points. I'm going to number these pieces, okay, because y'all are doing this all in the same color, whereas I'm using different colors. Piece 1, piece 2, and piece 3. The first thing we're going to do is make a table of values for piece 1. Okay, X, Y. Do you make a table of values, Tony? I draw the graph and we make the table of values with the graph. That's what I'm going to do, but my graph is on another page, Tony. So a table of values on the graph. You know, I guess that's a good idea. Okay, I'll do that. Here we are. Let me move the function down and there. Maybe it's. I'm going to go ahead and unzoom this on so you can see that more. So we're making a table of values, x and y. The first number or numbers you must plug in are the cut points. The first number I have to plug in for x in this blue piece is -4. And you say, well, wait a minute. X can't equal -4. That's right. We'll discuss why we're doing that in a moment, okay? But for now, I'm telling you we have to use that cut point. Since x can't, there's no equality, how did you label solution cut points when you were plugging the number in and there was no equality? Solution cut points with no equality, how were they labeled on the number line? Open circle. You're going to use an open circle there. But y'all said we needed 2 points to draw a line. So we need another x value. This is a number you're going to choose on your own. You choose a number that's less than -4. Be careful. Could I use 0? No, 0 isn't less than -4. You choose a number that satisfies this condition. What do you want to use? No, smaller than -4. -6, okay, we could use -6. We could use -5. I'll use -6. Now realize, is -6 a cut point, the number that you just made up? What are the only cut points in this problem? -4 and
5.
And 5. So negative 6 isn't a cut point. The points that you're using on your own, that you just make up on your own, are automatically regular closed dots.
So they look like closed circles, but they're just dots.
Plug in negative 4 in for x, we get 2 plus 3 times negative 4. So we have 2 plus 3 times negative 4. 3 times negative 4 is negative 12. 2 plus negative 12 gives me 2 plus negative 12, I agree with negative 10. Plug in negative 6. Plugging in negative 6, what are we going to get? We'll have a 2 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Not going to have enough room.
I'm not going to have enough room, am I? Okay. Oh, that's still. What are y'all getting when you plug in negative 6 into the blue piece? That'll be a 2 plus 3 times negative 6 is negative 18, which gives me negative 16, I agree. So we go to negative 4, negative 10, and we have an open circle. Did you pass out graph paper?
Yeah.
Maybe if they counted units of 2, do you think that would be better, Tony?
If you want. If you're going to have to plot that point left 6 down 16.
So at negative 4 we go down 10.
But then you can't see any of that.
Oh, okay, let me move it up. There it is. And that's the smallest we can make it?
No, that's the smallest we can make it.
So at negative 4, negative 10, we have an open circle. And then at negative 6, we have to go down 16.
Wait, so
Negative 6, we go down 16.
Everything just looks black up there. I can't tell that's a blue, but okay.
It's
It's blue, I can tell. I know it's blue.
You start at the cut point, and you go towards the second point that you found. Notice, x less than negative 4, that just starts at negative 4 and goes to the left. Does that interval ever stop?
No.
No. So the left side of the graph never stops. Notice there's there it is. I should have let you use your graph paper, Tony.
Yeah, okay.
Now the second piece. Everyone got that first piece?
Got negative 4, comma, negative 10, open circle. Then the other point is just a dot. You could have chosen any number to the left of negative 4. Negative 5, negative 6, negative 7, negative 8. Use negative 6. So left 6, down 16.
Okay, now the second piece. Here's the second piece. Okay, so this is a purple table. The piece is in purple, so we'll use purple ink, or I'll use purple ink. You're just using your pencil or pen, but I'm the only one changing colors here. I like this middle piece. Remember I said the first number or numbers you must use are cut points themselves. There's no free will here. What two numbers must we use for x values? We're not going to be choosing a point like we did right there. We have to use negative 4. We have to use positive 5. And did I didn't miscopy this. Both of those had equality, right?
Let me make sure. Yes.
Yes, they did. Okay, so both of these cut points are going to be labeled how? Open or closed? Closed, I agree. Plug -4 into the purple piece. -2 times -4, what's that going to give us? +8, I agree. Plug 5 into the purple piece. -10, I agree. -2 times 5 gives me -10. So I'm coming down here. Here's my graph. There it is. At -4, I have to go up +8 units. So -4, I go up +8. I have a closed dot. And then what's the other point? 5, -10. Count to the right 5. 5. I go down 10. And what sort of dot do I have here? Another positive dot.
Closed dot.
Closed dot. Okay, here's the question. I have these two cut points. Will I have arrowheads on them? No, there are no arrowheads. This interval does not go on and on forever. That interval starts at -4, it stops at +5. It started at -4, it stopped at +5. So if you have two cut points in your inequality, you have a starting and a stopping point. No arrowheads, it doesn't keep going forever. What do y'all think for the green piece? For the green piece, will we have an arrowhead? It's going to start at 5. Is it going to stop? No, so we will have an arrow for the green piece. Let's do the green piece now. Y'all are quiet. Are they always so quiet, Tony?
Yeah, they're usually really quiet.
Really? Okay. What's the first number I'm going to plug in for x? 5. That's a cut point.
Open a closed circle there. It's going to be an open circle.
Open circle. There's no equality. Now we need another x value, one that's bigger than 5. Could I use 0? I always like to plug in 0. 0 is easy to plug in. Can I use 0? No, 0 isn't bigger than 5. 6, let's use 6. Is the second point that I'm making at myself, is that going to be an open circle? No, it's going to, anything you choose on your own has to satisfy the inequality, so it's going to be a regular closed dot. Plug 5 into the green piece. What's that going to give us? 2 times 5, I agree with 10. Plug 6 in. 12, I agree. So, every time I touch my lapel, this microphone is catching the static. I'm sorry about that. Okay, so here we are at 5. We go up to 10. Open circle. There's 10. And then we have 6, 12. There's 6. We're going up to 12. And y'all said this was going to be what, sort of a circle? Closed. It starts at the cut point. It goes to the other point. Does it stop? No.
Generally, it's at the ends of the graph that you have the arrow.
That's correct.
Okay, you don't generally have an arrow in the very middle of the graph. And certainly not at the cut points. So why don't you lift it up so we can try to see as much as possible.
Yeah.
That's as unzoomed as possible without doing a physical zoom.
Okay, let's choose the correct graph.
Okay, so let's try to remember what it looks like.
Remember what it looks like, okay. So it's down, up, and it's falling from left to right in the middle.
Okay, it's falling from left to right in the middle. Okay, I'm going to just pop out each one of these. It's not that one, right? The middle term is, the middle part is wrong. Hey, every part is wrong, isn't it? Okay, let's see, what about this?
Hey, that looks
that's
good.
It. Open circle, down, okay, I think that's it, but let's just knock out the other ones. Not that one. And no, okay? So it is this one here.
Yes.
Okay? So, let's see, okay. All of that, and it was just multiple choice, and we all are just going to guess at it and see.
And now, before we go on, a sensible question. Can you switch back, Tony?
Okay.
A sensible question is, we'd already said when we're evaluating piecewise functions, you can't plug 5 into this green piece because x can't equal 5. Why did we use 5 when we were graphing it? The real number system is dense. Between any two real numbers, there are infinitely many other real numbers. I claim that there are numbers on the x-axis that are bigger than 5, but they look to the naked eye, it looks like 5. For example, here's my green table, 5.00001. Do you agree that that number is bigger than 5? Yes, just barely, that 0.00001. It's bigger than 5, so this point has to be on the graph. So you plug it in here, 2 times 5.00, that's going to give me a 10.00002. This ordered pair is on the graph. It's definitely on the graph. If I told you to come and label this point on the XY grid, what would it look like? Wouldn't it look like, to the naked eye, it would look like 510. So you have that open circle there. You're saying that 510 is not on the graph, but there are plenty of other points that look like 510 that are on the graph. Infinitely many points that look like 510 are on that graph. And if you say, well, how can there be infinitely many? Just keep sticking in another 0. Put another 0 before you get to the 1. You then have another 0 there. We could do that forever.
Really making it good. It looks so neat there, Tim.
Oh, thank you. My penmanship award still comes through, Tony. You see, we can just keep sticking more and more zeros before the 1, and we're getting all these points that look like 510 to the naked eye, but they really aren't 510. So that's why we have to plug in the cut points, even the ones that don't have equality. -4 doesn't satisfy that condition, but there are infinitely many points on the numbers on the x-axis that are less than -4 that do satisfy the condition.
-4.00001, for instance. Okay, but enough about that.
Okay, Tony.
It's time to go on and do
I'm going to let
one.
you go. You've been doing this more than I have lately, so I'm going to leave you to it.
I was seriously considering when I stepped out of the room, going on up to my office. I've been having back pain lately.
I tell you, we can't get a break.
I know, I'm aging terribly.
55 years of good health, and then just boom.
Boom. Okay, so next we're going to do problem 3. Number 6. 6 is the only one that has 3 pieces. If you can follow the one that has 3 pieces, then the 2-piece ones are going to be very, very easy to do, or it seemed like it. So this is problem number 3.
And while he's writing the problem down, I want to tell you, if you have both an open circle and a closed circle appearing at the exact same spot, your graph has a closed circle. Closed circles take precedence over open circles. And you could have them both appearing, so you'll see what I mean in a moment. Just remember, if they both appear at the same point, your graph has a closed circle.
But if you have it nice and colored, you can sort of show more than if it's all in just one. Okay, so f of x equals x minus 3 if x is less than or equal to 1, and negative 4 if x is greater than negative 4. Well, I'm going to draw my rectangular coordinate system and decide where each piece goes. We're going to have a black piece and a red piece.
There's only one cut point. What number's the cut point? Negative 1. Okay.
So I'll draw my rectangular coordinate system. Now this is one that would fit on those that graph paper I was passing around. And I'm going to locate negative 1 on the x-axis. And I'm going to go ahead and decide where each piece goes right now. The black piece is going to be, we're going to have a black graph for x's less than or equal to negative 1. Let's not worry about the equal right now, just less than negative 1. Would that be to the left of negative 1 or to the right of negative 1? Which way is to the left? If you look at this symbol, it sort of points in the direction, right? You're going to have the black graph to the left of negative 1. So over here we'll have a black one. And for x is bigger than negative 1, look at how the symbol's pointing to the right of negative 1. So I have my red XY table over here. Where's that one that we just finished graphing? Looking at this number 6 again, notice how it's pointing to the left. So the blue graph is to the left of negative 4. Now the one that has the 2 less thans, that's the between. There shouldn't be any doubt about that. Here to the right of 5, notice it's pointing to the right, so bigger than 5. Okay. So I'm going to do this first one. You've got to plug in the cut point. The black cut point, there's only one cut point, negative 1. So plug in a negative 1 into the black function. And what are we getting for the y value? Negative 1 minus 3. Is that a negative 4? Yeah. Okay. That'll do. And then, okay, so we have a, oh wait, what did y'all say? Open or closed circle at that point? Closed. So we have a closed circle at left 1, down 4. 1, 2, 3, 4. And now, it's up to you for the next point. You're going to have to choose one to plug in. I'm going to give y'all a choice. Should I plug in 0 or should I plug in negative 2? What number should I plug in? Well, it's got to be to the left So -2, -3, -4, whatever you want to use. I'll use -2. -2 minus 3 is -5. And that's a dot there. Looks like a closed circle, but you'll notice on the answers, they'll show the open and closed circles clearly, but these little dots, they don't show those.
Because you may choose a different number.
Exactly right.
Every student.
See, left 2, down 5. 1, 2, 3, 4, 5. So there's -4, there's -5. I almost should have drawn it bigger. It's got to be to the left of -1. So -2, -3, -4, any number to the left of -1. That black graph must be to the left of -1. You're choosing an x less than -1. Okay. Now I'm going to connect. You see, notice the closed circle and the dot sure look alike. I'm going to connect the closed circle and the dot and draw it how? Do I draw it up like this? Like that, or do I draw it down like this?
Always start where? At the
cut point.
At the cut point, okay.
So do I draw it down, or do I draw, oh, well, there. I have a black graph to the left of -1. Now we're ready to graph the red part. And the red part, at times students think it's difficult just because it's easier than the others. This is one of those constant functions. What do I mean by a constant function? Notice the little formula rule here doesn't have an x. There's nothing to actually plug into. Doesn't matter what the x value is, the y value is -4. So I'm going to go ahead and put -4 there and there.
What's the first number you use for x in the red piece?
It's gotta be that cut point. And this cut point will have an open or closed circle. Open because there's not an equal sign. Now, I'll give you the same choice. Well, I need another number now.
A number that's actually bigger than -1.
0? Mm-hmm. Now that, you chose that, so it's just a dot. Looks like a closed circle though. So left 1, down 4. This is what my brother was talking about. I just had an open and closed circle in the same spot. But since I'm using different colors, I'm going to show a red open circle and then a dot, 0, -4. And I connect them, and the red graph should be to the right. Ooh, it should be right there. Ooh, there. Pretend that's a nice, pretty red line there. The way, by using the different colors, I can show the black graph has the closed circle, the red graph has the open, but you don't see it in multiple colors or different colors when you look at the answer choices. So what it'll show when there's an open and closed circle all at the same spot, it just shows a closed circle. Okay. But if you were doing it in color, then we could show, oh, the red one is the one that has the open circle, the black one has the closed circle. Okay. But if it were all just black, you really couldn't show that. So,
you could fill it in. Look, there it is.
Okay, fill it all in.
I did.
Okay.
There. Okay. Okay, let's choose the correct graph.
Let's see. Is it that one?
Oh, did y'all finish? Let's see. Y'all finish that? Yes? Because y'all got to be looking at that to tell me which one.
And then right, okay.
Was it this one? No. This one? No. C?
I'm thinking that's it.
And that's a closed, notice they're just showing the closed dot. open and closed dot at the same spot, your graph is going to have that closed dot or closed circle, whatever you want to call it. Let's just look at D. No, you're right, it's C. Okay. Oops. Well, I think we've done enough of these. Maybe we better go on to quadratics.
Yeah.
If we have time, we'll come back to one of these, okay? And do another one. See if
What time is it now?
8:55. We have 20 minutes till the break. I hate to tell y'all this, but this is a long section. It's going to take the full 3 hours, but we'll have our 10-minute break, so don't start panicking yet. And let's see.
And we're going to end off with what's the least favorite type of problems you want. No, okay. Okay, then good. Lucky for you. You're going to end off with word problems. So, those aren't y'all's least favorite, then I'm glad about that. Okay, so we've already seen the word quadratic.
I'm going to.
Oh, just switch over here. I want to tell them some stuff before we actually start doing problem. Okay, so we've already seen the word quadratic this semester. Right off that first week, we were looking at quadratic equations. Quadratic means there's an x square in it. So a quadratic function is in the form f of x equals ax squared plus bx plus c. And the graph of a quadratic function is called a parabola. Just like the graph of a linear function is called a line, the graph of a quadratic function is called a parabola. A parabola is a U-shaped figure that'll open either upward or downward. Now, you can decide how a parabola opens just by looking at that first number, the coefficient on x squared. If a parabola, or if a is a positive number, a greater than 0, that's how we symbolically write positive. If the number a is positive, then it's going to be opening up. If the number a is negative, it opens down. The first example, or the example, the example we're going to do before the break is problem 9. I'm not ready to do it yet, but notice here's a quadratic function. Looking just at that first number, how is it going to open, up or down? It's opening downward, okay. But we're not ready to do any more than that. Now, every parabola has
note. It's going to open downward, okay? This is number 9, just so we remember that.
Okay. Every parabola has a turning point called a vertex. It's that turning point. And every parabola has something called an axis, which is a vertical line that cuts it right in half.
If you could fold the paper down that vertical line, the right side of the graph would lie directly on top of the left side. They're mirror images.
So we have a vertex. That's the dot. The axis is the vertical line. Oh, I suppose sometimes students are wondering, well, wait a minute. Why aren't any of these opening left or right? And you answered that question in your homework the last time.
Yeah.
If you have a parabola opening left or right like that, do you remember that vertical line test? Is this thing even a function? No. There was a homework problem in the last assignment where there was a curve like this, and it asked, is it a function? And you used the vertical line test to say no. So we're only looking at functions from here on the rest of the semester. So that's why it's only opening up or down. Now let's see.
There are two methods of determining the location of the vertex. One of them is completing the square, and I think that's just ridiculous. It's like using a chainsaw to cut butter. You have to complete the square to find the center of a circle when it's been expanded. Y'all may remember that. It was really messy, and it was one of those lessons that I was glad I wasn't here, okay? Because that's such a messy thing to do, completing the square. But there's another way of finding the vertex, and it's called the axis formula. X equals negative b over 2a. It is another formula you have to remember. But you've already memorized the quadratic formula. This formula, I'll tell you the easy way to remember it. The quadratic formula, x equals
negative b plus minus square root blah 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 all over 2a. This vertex formula is the quadratic formula without any of that plus minus square root stuff.
Why should I do that?
Negative b over 2a. That's not anything I need to see.
Oh,
okay. Negative b over 2a. The vertex or axis formula. You can call it either one, the vertex formula or the axis formula. You'll see why I say either one is fine.
Notice, depending on how the parabola is opening, the vertex will either correspond to the low point on the graph or the high point on the graph. If the vertex is the low point on the graph, then that means that's the smallest y value on the graph. And so we say that's the minimum y value.
Now what's the corresponding M word that we would say over here?
Here's the biggest y value on the graph, so that's the maximum.
I'll give you a hint right now for the 3-word problems that in the homework. You're going to be finding that minus b over 2a and plug it in.
Because they're going to be asking either for a minimum or maximum. Well,
we're getting
where would the maximums and minimums occur? At the vertex. There's a minimum if the parabola is opening upward. There's a maximum if the parabola is opening downward. Maybe you should define domain of... I guess you've already defined domain of range, haven't you?
In fact, I want to mention for a quadratic function, these arrows mean that it's going to continue going left and right. It's going up or down also. But y'all remember a rule that we had? You had a homework problem where it said find the domain. I think it was problem number 15. I might be wrong. But there were no fractions and no square roots. What did we say the domain of a function that has no fractions and no square roots is? Negative infinity to infinity. When they ask you what's the domain of the quadratic function, you just write negative infinity, comma infinity. This is another one of those times where you have to type that. Now for the range, that's going to take a little bit of thought looking at the graph. But now, I also want to define increasing and decreasing. You might think, well, that's stupid. I know what increasing means. It means getting bigger. Well,
algebraically, increasing and decreasing is measured looking from left to right. Right here, you see arrows and they're going up, and you think, oh, that's increasing. No, what's happening when you go from left to right? Reading from left to right, trace it along. Is it going up or is it going down? You see my cursor? Is it going up or is it going down? It's decreasing, it's going down. Decreasing is falling from left to right. It reaches that vertex, and then what does it start doing here? It's increasing, it's rising from left to right.
Okay, so help me out. How do I, over here, it's decreasing and then increasing. So I'm going to write DEC over here, INC there.
What about this one?
Start here, trace left to right. What am I
Don't say it. Let it increasing or decreasing? Increasing, yes. It's rising from left to right. Good.
And then decrease.
I agree.
Okay. And I think we've told you everything we need. Oh, except how to graph these things. In order to graph one of these, there's going to be a little graphing tool. I'm just going to make an XY table. And y. We're going to basically plot that vertex, minus b over 2a, and then any other number other than minus b over 2a. So you find minus b over 2a, plug it in, and then choose any other number, plug it in. There'll be a graphing tool for that.
When you're choosing that any other number, I'll warn you right now. If you decide, I'm going to plug in 100, you'll probably get a number that won't fit on the grid. So any other number, the number you choose, I recommend you choose a number real close to the vertex. Don't go more than 2 units away. You'll see what I mean in a moment.
If minus b over 2a turns out to be 3, use either 4 or 5. No, use either
1, 2 or... You could use 1, 2, or 4 or 5.
I think on number 9, if you go even 2 units away, it might be too big. But let's see. 7, 8, 9 are all the exact same problems, except number 9 is the one that has bigger numbers in it. So that's why I want to do that one as the example. So let me write it down. Number 9, f of x equals negative 3x squared minus 24x minus 36. And, oh, wow, this is one of those problems that just keeps going and going and
love
going.
it when they have all these different parts that you get to go through.
You get any one of them wrong, you still got to keep going and going.
And then you got to rework the whole problem if you want to get it all right. You just love that.
I remember they asked, we were meeting with some Pearson people, and they asked, no, I did a review for the book. I got my little name in it and stuff. And I could tell that people were thinking, why did we ask this idiot? They were asking me, what could we do differently about this? And I said, you have these problems, some of them have too many parts. And I specifically listed this problem.
Did they make a change? Did they make a change?
No.
It's
one of those, they sent me my check, and then they took my little thing and threw it away. That idiot. So,
remember, he said that you're going to be using any other... Oh, wait a minute. Oh, okay. Any other number? Look over here. What's my favorite number to plug in? I think it's the easiest number to plug in. 0? Because anything with a 0 becomes what?
Yeah, 0.
What are you going to get for that y value if you plug in a 0?
Yeah,
negative 36. It won't let you count up count up or down 36. I think none of the grids will let you go up more than 20. So when you're choosing that number, you can't just choose, I'll use 0. That's easy to plug in. It won't let you graph it.
Okay, so
here
switching back, we're going to start off. We've got to find that vertex. So the vertex formula minus b over 2a. Remember, a is the coefficient on x, and a is the coefficient on x squared, b is the coefficient on x. So, we better be careful. This minus b, we have a minus.
That's the minus from the formula.
And then b is a red negative 24, so it's going to be a positive 24, minus. Over 2 times a, what's 2 times a going to be? Negative 6. So positive 24 over negative 6, negative 4. So if we start making our little XY table, which is what we're going to have, plug a negative 4 in for x. And this would be a good one to use my calculator on. I haven't used my calculator in a while. Let me pull up my calculator.
Does that make the display a little brighter? It seems it's so bright in here. I just don't notice. Our screen is crystal clear, but y'all, that seems a little pale, doesn't it? Is it always like that? Yes. Is it better with the lights dimmed a little bit? Yes? Okay. I'm just coercing y'all into saying what I want you to say.
How do you?
It's really clear here. Are these clear? I dim the lights just a little bit. Yeah. Oh, y'all found the sign-in sheets, right? Okay. Is that better or not? Are you going to get sleepy? Okay.
So what am I doing? I'm plugging -4 in for x, okay? So I have -3, then, well, -4 squared we know is 16. So if you just want to say times 16, that's fine. Then a minus 24 times -4, and a minus 36. 12? Yeah, that's right. Okay. So -4, 12 is 1 point on the graph. And we need one other point. I say only go one above or one below.
Yeah.
So you either use -5 or -3. Don't go real far away. Don't go to 0, because if you get 0, that's going to give you a -36. It won't be on the graph. Okay? So how about,
what do y'all want to use? Either -5 or -3.
-5? Okay, so plug a -5 in there. Squared minus 24. And did I hear 9? Yeah, I agree with that. So I think we've done enough already to start.
Remember, we said
on
the
the
parabola was going to open down because of that negative.
So we've got to look, make sure it does. So, okay, let's switch on over and see the problem. I think the first thing it asks you to do is type in the vertex. The vertex is an ordered pair. It's that -4, 12. Okay. Don't just type -4. That minus b over 2a just gives you the x coordinate of the vertex. You want that whole ordered pair listed.
Now they want us to draw the graph. What did you do? Did you use the pop out?
Well, either way, if we're going to use it, you still got to get it click to enlarge. Okay.
Oh, look, it's only letting you go up 20 and down 20.
See, that's why you can't plug a, theoretically, if you were doing it by paper, you could plug a 0 in and get a -36, but not here. So, let's choose our tool.
Choose a tool. Let's have her. This object selection tool, you'll never use that, okay?
Well, let's just
There's
say
only one symbol, I know, but there's a line. It's not a line. We know the V. The V is the absolute value. Hey, what about this thing? That looks like a parabola. What does that say? Can y'all read that? Vertical parabola tool. So even though it's opening downward, this is a vertical parabola. Now what about these horizontal parabolas? Are you going to be drawing any of those? Because they're not functions. And we know what this thing is.
It's not a circle.
So we click the vertical parabola tool, and what does it say to do next?
Plot the
vertex.
Oh,
the vertex
gosh. -4, 12.
-4. Y'all see where it's showing the ordered pairs?
Upper right-hand corner.
Is that it?
Yellow rectangle.
One more, I agree. Is that it? Yes.
Now move that cursor around and you'll see every type of parabola that'll have that vertex. There it is. Okay. Which one do we use? Plot another point. That's where we plot the -5, 9.
-5, 9. Is that it?
You're at -5, 9? Yes. Okay.
Now notice, if you had plugged in -3 for x, you would have still gotten 9 for y. So you'd still have the same graph. Remember I said these things are mirror images. This tool is very nice. You plot the vertex, and then you plot one other point. That one other point, the graph then uses, the program uses symmetry to draw the mirror image.
So that's exactly what you would do if it were multiple choice. The vertex and one other point.
Save it. That transfers it back to the original grid, and then check answer.
And you think we're finished, but oh no, we are not. Okay, now it says the axis.
Well, notice it says type an equation.
No,
it's not just -4.
Axis.
Let me see something. Maybe I can make this bigger.
Oh, okay. Oh, look, Tim, when you do that, you see.
No, then we lose that. Okay, there.
Well,
okay.
first I wanted to remind them of something that I'd written. Axis is that vertical line, and this formula I said could be called the Vertex Formula or the axis formula. The reason it's actually, this is the axis. X equals, let me pull it up. For this, if we were drawing a vertical line straight through it, it would be there at -4. X equals -4.
Remember we had said that vertical lines have an x in their equation and no y. Horizontal lines have a y and no x. So x equals -4 is the equation of that vertical axis. It's not just -4. It's x equals.
And it's not just a big coincidence that this number and this number are the exact same. They've got to be. Okay? So you just take that x coordinate of the vertex and say x equals to get the axis.
The domain. No fractions, no square roots.
What's the domain going to be? What was that rule about? No. If there's no fractions and no square roots, the domain is all real numbers at -infinity to infinity. For every one of these, when it asks, what's the domain, you'll say -infinity, infinity. This is one of those times, okay. Oh, do you want to type it in? Oh, -infinity, infinity, close parentheses. It should be nice if they had the little button down there you just click. Okay. Now the range, that's going to take a little bit of thought. The y values are not -infinity to +infinity. We just look at this graph here. This graph, the way it is, it starts at this point and it just keeps going down. It's not going up.
Now, if you were graphing on paper, there's the vertex, and there's that secondary point. So there it is. It's going down like that.
Notice how it just keeps
There's
going.
-4, -4, +12, and -5. There's that secondary point. We drew the left side, and then just drew the right side by freehanding it. I have a question. Does this vertex correspond to the maximum y value or the minimum y value? Maximum y value is the highest point on the graph. Okay? And Tony, what I do is I say, okay, imagine taking this graph and reflecting it over onto the y-axis. So it starts there at that 12 and it goes down. Does it stop? So for the range, we have to make it write it in interval notation. Remember, interval notation goes small to big. So, how would we say that? What's smaller? This thing keeps going forever and ever, so that's a -infinity down here. What's smaller, -infinity or +12? -infinity. What do you always put in front of a -infinity? A parenthesis. And 12. I agree with the bracket. 12 is used. It's used as a y-coordinate. It's used right there at that vertex.
So the y values start at 12 and just keep going down, 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 down. If this parabola had been opening up, the y values would start at 12 and go up, 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 up. Okay?
Type it in. We're almost time that we're going to go into their break.
Oh, parentheses, negative infinity, comma, 12, bracket. Oh, there. Okay. Okay, now let me do the increasing and decreasing. It says find the largest open interval of the domain over which the function is increasing. Well,
remember it changes at the vertex, and here's the x-axis, because they said the largest interval of the domain, so you're looking at the x-axis. So it's going to change at -4.
So over here, is it increasing or decreasing? Remember, you go left.
I can't see it.
Oh.
Thanks.
Okay. If you trace along here, is it increasing or decreasing?
Increasing.
It's increasing to the left of -4. Let me make a note of that. Increasing to the left of -4. And then it starts, is this decreasing over here? Decreasing to the right of -4, but we're not going to write this out in words, of course. We're going to write it in interval notation.
You know what I do is right here to the left of -4, there, I write increasing, and over here it's decreasing. So you're actually looking at the x-axis when you're writing the interval notation.
Oh, okay. So what's the interval notation for left and -4? That would be negative infinity to -4.
And they say open interval, so you don't have to decide whether you want to include the -4 or not.
I think that's the first time they mentioned that.
Yes.
Okay.
It's the author prerogative, and they're choosing to not include the number.
Open. I need to define open interval. Open interval means
Parentheses.
both two parentheses. So they're saying use a parenthesis here at this number, not a bracket. Why open? Well, remember, open circles, parentheses. Okay. Now, what about to the right of -4? It would be -4 to infinity. So it's increasing to the left of -4, or from negative infinity to -4. It's decreasing to the right of -4, from -4 to infinity.
Increasing, you said it's increasing to the left, so negative infinity, comma, -4. And remember, it's the interval of the domain. That's why you're using the -4. You don't use the 12. That's not a domain value. The domain is on the x-axis, and decreasing -4, comma, positive infinity, right parenthesis.
Now, a few years back.
What did I just do?
Control. Let's stop. A few years ago, a student asked me, "Could you say?" Oh well, you still can't see it all. She was like, "Oh, so this number here, the y-coordinate of the vertex, it will appear in the range. This number here, the x-coordinate, it's going to appear in everything else. Well, not the domain, but the axis and the increasing, decreasing." And yes.
That's
okay?
a good observation.
-4, -4, -4. When she asked me that, I was like, well, wait, let me think. And I was like, yeah, okay, you're right. This second number here will always be in the range. This first number, the -4, the x value, is going to be in the axis and in the increasing, decreasing. Okay?
Okay, we'll take our 10-minute break. Realize that if you're leaving us now, those word problems, they'll be asking for maximums or minimums. Where does a maximum or minimum occur on a quadratic function? It starts with a V. Vertex. So my hint to you on those word problems, you're going to have to use the vertex formula and plug in that number.
Do the -b/2a and plug it in. That should answer every one of the word problems. But we should have time to do all 3 of them when we get back. Okay?
Okay, let's meet back here at 9:35.
If you're coming back.
And hopefully you are.
Okay,
no, don't. Okay, let me see if I remember to do it.
No, that didn't stop it. You've got to stop it. It's still
How do I stop it?